Okay, guys, here's Timmy coming at you again, and we're going to go over a little bit of a review of what we've learned over the last couple of classes. So remember, if you look, there are two main classes of compounds in the body. They are organic compounds, and by definition, an organic compound, my definition, it contains carbon, hydrogen, and oxygen chemically bonded together. So if you see here, you got a carbon, a hydrogen, and an oxygen chemically bonded together. So this is organic. This little chemical, and you don't need to know the chemical formula or structure. This guy is glucose. And glucose is an example of a carbohydrate. Then you got this guy here. Again, look. Carbon, hydrogen, oxygen chemically bonded together, just in a different way. So this is fat. And then finally, you got the guys who are really important, the ultimate players in the body. You have the amino acids. And these guys are so important. I'm going to give them their own special slide. I should have done this years ago. I don't even know why I didn't. Probably because I was busy doing something. Like maybe working on my golf game or something. Anyways, there we go. We talked about the fact that in the body, you have these amino acids. And again, who cares about the structure? Learn that, go to grad school, or study on your own. So if you look, carbon, hydrogen, oxygen, chemically bonded together. But the unique thing about that is these guys have this nitrogen compound, this NH2. And even though that says NH3, never mind, don't worry about it. This guy there is the amino group. So this is what makes different the amino acids between the amino acids, the carbs, and the fat. And these guys are really important. They're the most important organic compounds in the body. And you have 21 individual amino acids. And what amino acids do is if you string them together, so if you take individual amino acids inside a cell and you string them together, chemically bond them together, right? I'm making this up. You make a protein. So, again, and the two big classes of proteins in the body are structural proteins and functional proteins. So, the structural proteins, they provide the framework of your body. So, what kind of holds you together makes you are structural proteins. So you got your hair, collagen, I could go on. Nails, those are all structural proteins. So they help build you. The ones that are really critical, well, they're all critical, but this is more critical, are the functional proteins. And the two classes of functional proteins are enzymes and hormones. So let's talk about those guys, the functional proteins, the ones that make the stuff happen in your body. By the way, without these functional proteins, these enzymes, uh, you wouldn't be around very long. So again, enzymes are proteins. And again, proteins are made of amino acids chemically bonded together. And enzymes control all the chemical reactions in your body. So think of enzymes as like little workers and like on a line at a factory. Some products coming down the line, and your job is to put on a bolt. That's all you do. You put that bolt on, and then that little product, whatever you're making, slides down to the next guy, and he puts a nut on that bolt. That's all he does all day, 8 hours a day. So enzymes are specific, meaning they can only make one type of chemical reaction happen. If you need to have another chemical reaction happen in your body, in your cells, then you got to send it to another specific enzyme that just does that chemical reaction. So let's get back into this. Enzymes control all the chemical reactions in your body. Now, what I'm going to stop and take a moment of silence, because the next thing I'm going to try to explain to you is critical. And ultimately, this is how all people end up dying. Enzymes are proteins. And proteins are amino acids chemically bonded together. Little dash is a chemical bond. I don't care. I'm making this up. So in your cells, when you have to build an enzyme, you will put together the amino acids. I'll explain that in a minute. Just take this on faith right now. So you take the individual amino acids that you got from eating a steak or Joe Weider protein powder, and those amino acids get inside your cell, and they will help you build enzymes to make the chemical reactions inside your cells happen. So when you string them together, you make a protein. All right. So watch. I'm going to go back to the alphabet. 26 letters. Let's string together a difficult word. C-A-T. Here, kitty. Anyways, watch. This is the big point. When you put together a word, not only are the letters that you use important, but is the sequence in which you put the letters. So if you take those same letters, C-A-T, and you put them in a different order, you have a different word. So letters make words, individual amino acids strung together make proteins. So not only are the individual amino acids that get chemically bonded together determine the protein, it is the sequence which you put those amino acids together that ultimately determine the protein that you make. So if you have this protein right here, amino acid 4 combined with amino acid 8 and amino acid 12, if you take that and you put amino acid 8 first, amino acid 4 second, and amino acid 12 third, you have altered the sequence of those amino acids. So you will no longer have the same protein. So this is critical. Watch it. Are you watching? Write this down, tattoo it someplace. I don't know. Maybe on the, let's see, maybe on your neck, on the left side of your neck. So when you're looking in the mirror, oh yeah, I remember it, right? So watch. Each individual amino acid carries an electrical charge. Got it. Positive, negative. Yeah, simple enough. So watch. Inside the cells of your body, once you string together those amino acids, and I'll explain more about that later. Right now, just get this. Yeah, you've made this protein. What did I tell you? Each individual amino acid carries an electrical charge. Again, I'm making this up. So amino acid 4 positive, amino acid 8 negative, amino acid 12 positive. And when you string those together, once you've strung them together, the charges on each one of those individual amino acids they're going to interact. Opposites attract, yeah, and like charges repel. So once you strung the individual amino acids together, those charges are going to interact, and I'm making this up. I'm not sure what it would look like. Here's the point. So once those charges interact, it's going to cause that protein to bend and twist and have a particular shape. And, oh God, this is so critical. The shape of the enzyme determines its function. Just like a key to your house that unlocks your door, it is shape specific. If you take the key that normally opens your back door and you take the pliers and you bend it, it will no longer open your back door. So the amino acids that make up the protein and then ultimately make up the enzymes perform all the chemical reactions inside your cell. And what's important about the shape? Let Timmy tell you. The shape determines its function. So if you alter the shape of an enzyme, you will alter its ability to perform chemical reactions. And sad as this may sound, all we are as human beings is a ton of chemical reactions. And what causes all those chemical reactions to happen faster in your body? Yup, you got it. Enzymes. So here we go. Again, the shape of that protein, and in this case, the shape of that enzyme, is going to determine whether or not that enzyme can do its job. So I got a call last night from an old girlfriend, and we're going to go out. And because I dated her a long, long time ago, and I looked a little bit better, I had hair and a lot of other stuff. Anyways, but I want to look good for her. I'm going to try. Here we go. What's hair made out of? That's right. Hair is protein. So tonight, when I come back from making futures at Gateway Technical College, I'm going to go to the bathroom and I'm going to take my curling iron and I'm going to apply heat to my hair. And when you apply heat to your hair, you change the shape of that protein that makes up your hair. So I went from straight and bald to curly and bald. So watch, watch, watch. What's the goal of the body? To maintain homeostasis, to maintain that internal balance that's critical to the optimum functioning of your body. So watch. What controls all the chemical reactions inside your cell? Uh-oh. Enzymes. What are enzymes made out of? Cut it out, Timmy. Protein. What's important about that protein? The shape determines its function. What do you want to do? You want to function optimally. So watch it. At what body temperature? At what body temperature do the enzymes of your cells work optimally? Work the best? Uh-oh. It's 98.6. So why is our body's temperature 98.6? Because that is where the critical enzymes of your body, specifically your brain, work the best, because at 98.6, that shape of that enzyme is optimal. And when it's optimal, it performs the best chemical reactions. So watch it. If you get a fever, say you get a fever of 103, how are you going to feel? Hey, let's go run a marathon. Or better yet, let's read the textbook. Yup. Well, maybe in a delusionary febrile, right before you seize, you might think about reading the textbook. But anyways, I digress. So if you have a fever, you don't feel good. And one of the reasons you don't feel good, you don't have a lot of energy, you feel weak, is because as the temperature of the body goes up, what does it do to the shape of the enzymes? It changes it. It changes the shape of that enzyme because you heated them up. And when you alter the shape, you alter its function. It doesn't work as well at a fever of 103. At what temperature does it work ideally? 98.6. Say yeah. That's beautiful. All right. So I reviewed with you a little bit today and the important parts of the functional proteins in your body. And the big guys are the enzymes. One more thing before Timmy leaves the building. And I'll go into this more. One of the things that is measured that doctors will order when a patient is really sick, when they are really jacked up, is they will order a pH level, a blood pH level. I'm just going to talk to you about this, and then I'll explain more later. So again, the pH really is a measurement of how acidic or basic the blood is. It's not a good sentence, but you'll get it. So watch. What's the goal of the body? To maintain homeostasis. The pH scale goes from 0 to 14, 7 being neutral. The pH of the blood, therefore the cells, has to be maintained between 7.35 and 7.45. If you alter the pH, if the pH becomes low to acidic or to basic, you die. And the reason you die is because of this. All right. Got another date. Old girlfriend calls. I'm like, who am I to say no, right? So I want to try to look good for her. So I'm going to try and work on this hair, which, to be perfectly honest, you just reach a point in your life where you look in the mirror and you say, I don't think so. Meaning the amount of work that you would have to put in to try to look even presentable is simply too much work. So I'm at that stage. Anyways, I'm going to try something anyways. So I come home, look at my hair, what's left of it, and I remember hair is protein, right? And the shape of the protein determines its function. In the case of hair, how you sequence those amino acids together will determine the shape of your hair, whether you have curly hair, whether you have straight hair. So I don't like my straight hair or what's left of it. So I'm going to go to the beauty parlor and get a permanent. What do they put in a person's hair if it's straight to make it curly? You're not going to believe this. They put acid on your hair. What does acid do to the pH? It drops your pH. Your hair now becomes more acidic. And when you change the pH of your hair, it will cause hair that was straight to become curly. Why? You've altered the pH of your hair, and when you alter the pH, it will alter the shape of the protein. Now you're following me, and you know where I'm going to go next, yes? So, why is the pH of our blood 7.35 to 7.45? Well, that's because the goal of our body is to maintain homeostasis. Those levels, whatever they are, where the body works optimally, and specifically the brain. So the pH at which the enzymes of your body, the cells of your body, those enzymes that perform all those chemical reactions, where do they maintain their optimal shape? At what pH? 7.35 to 7.45. So if your pH drops to 7, it will alter the shape of those enzymes, and those enzymes that perform all the chemical reactions in your cells of your body, specifically your brain, ain't going to work so good. If you alter the pH where it becomes 7.6, so it's alkaline, it's going to alter the shape of those enzymes and the chemical reactions inside your cell, and the most important ones are in your brain, will alter the shape of those enzymes, and they won't be in their optimal shape, so they won't work as good. So at what pH do the enzymes of the cells of your body work optimally, at least most of them? That's right. 7.35, 7.45. Yay, yay, yay. Ooh, oh, them Duke boys got my money. Bam. Now you understand why a fever's bad, or your body temperature gets cool, you're outside in the cold for so long, you don't work so good, or if you alter the pH. So again, the most critical component that you need to understand today is enzymes are made of protein. What are proteins made out of? Individual amino acids chemically bonded together. So not only are the amino acids that are used to make the protein important, but is the sequence in which those amino acids are chemically bonded together. Because if you alter the sequence, you will alter the shape of that protein. And if you alter the shape of the protein, it will not be able to perform its function because the shape of the enzyme determines its function. All right, that's all I got for you today. I'll come back at you in a few more days.